Hey guys, so in this lesson we're going to do quite a few things. Mainly we're going to use equations to make tables, and then we're going to plot points. And then these are some things that you've maybe heard your teacher mention, and I'm going to talk about them in all of our examples. The idea of independent versus dependent, choosing a good scale so that your graph looks good, and then something called continuous versus discrete. I'll mention that in all of our examples. Okay, so the way it's going to work is I'm going to describe a situation. So here we have a person that is buying sweets from a shop, okay? Now, you need to use this formula. Now, you see that so for example, if the person has 1 rand, you see that that's R, then you're going then you need to work out the value of S. So you're going to say S equals, now R is 1 plus 3, and so S will be equal to 4. So then you're going to go and you're going to put a 4 over there. Okay, so see if you can complete that table so long. So for this one here, you're going to say S is equal to R plus 3, and they're telling you that R is 2. So you're going to say 2 plus 3, which is 5. Pretty easy, hey? And then this one would be 3 plus 3, which is 6, 4 plus 3, which is 7, and then 5 plus 3, which is 8. Okay, now the next thing we're going to talk about is, well, let's go plot the points quickly, okay? So remember, this is your, you need to, on your Y, this is your Y axis. So, or let me rather explain like this. This top one over here, you're going to put that on the X axis, okay? So you're going to put that over here. And then this one at the bottom, you're going to put on the y-axis. Okay, so at the bottom here, you could say rand, and then if you know the units of rand, which in this case is measured in R, and then sweets, we'll just put on the y-axis. Okay, now let's see the numbers. Okay, so we've got 1 going up to 5. Okay, so that'll just be we could even put 1, 2, 3, 4. 5. We could even spread it out even more. The idea is to spread it out as much as possible. So 1, 2, 3, 4, and 5. See, that's nice. You want to spread it out as nice as possible. And now for the sweets, it's 4, 5, 6, 7, and 8. Okay, so I think 1, 2, 3, 4, 5, 6, 7. Okay, that works perfectly. So some things I'm going to mention throughout this lesson. So see how we started at 0, and can you see that here I went up with 1 each time, but here I did it differently. So you can do it differently on this axis, and you can do it differently on this axis. But once you've chosen something, then you must stick with that. So for example, you can't put a 1 here, and then you put a 2 here, and then a 3 there, and then a 4 there, and then a 5 there. No, it has to be spread out equally after you've chosen, okay? So if we chose that every 3 blocks will be a 1, then you must keep it like that all the way across. Okay. So that's choosing a good scale. Now, the one that's at the top, this one here, is your independent. Independent. And so your independent is here at the bottom. Independent. Okay? And then the one that's on the bottom here is called your dependent. And then that would be this one here, dependent. Okay, so we've spoken about independent, dependent. Now I'll talk about continuous and discrete in a moment. So let's go plot these points. So they're telling you that the one is, the rand is 1, okay? And then the sweets is 4. So where those two come together, you're going to put a little dot there. Okay, so there's where you're going to put a dot. Then they say the rand is 2 and the sweets is 5. Okay, so where those two come together, you're going to put a dot there. And then 3 and 6 would eventually go there. And then 4 and 7 would go there. And 5 and 8. Okay, so there's the drawing. Now, we need to decide if we are allowed to connect them, to put a line through them, because sometimes we can and sometimes we must not. So let's connect these two and let's see if this makes sense. Now this does not make any sense. Why does that not make any sense? Because let's say, for example, you look at this point over here, okay? Now if you had to read off what that is, what would that be? 4.5. You can't buy 4.5 sweets, okay? It doesn't make any sense. You can only buy 4 sweets, or you could buy 5 sweets, or 6 sweets. So we are not going to put a line through these things, okay? Because if you put a line through here, for example, then if you had to read this value off, let's say this value over here, then there would be 5.5 sweets, and that's not able. So you can't have half a sweet. You can only buy a whole sweet. So this is called discrete. Discrete. If we connected the line, some examples I'm going to show you in this lesson where we're going to connect the line, then we'll call it continuous, but this is going to be discrete. Okay, so there's our first example. That's all we needed to do. Let's go do another one, and we're going to do some interesting things as we go along. So here we have a similar scenario. So now they say a person is buying shoes from a shop. Now, to fill in the table, you need to understand, so this column, or this row, sorry, is the number of shoes. So maybe they bought one shoe, or one pair of shoes, 2 pairs of shoes, 3 pairs of shoes. And to work out the cost, which is measured in rand, you're going to use this formula. Okay? So to start, let's go fill in the table first. So to find the cost, you're going to use this formula like we said. So you're going to say C equals to 200, and then S is the pairs of shoes. So the first one is 1, so you're going to get C is equal to 200, so that's 200 rand. And then if you had to put a 2 in the place of S, you would get 400. If you had to put a 3, you would get 600, 800, and 1,000 rand. So on the x-axis, so remember this top row always goes down here, okay? And so there we can say pairs, I'm just going to say pairs shoes, okay? And that's measured in, that's measured in nothing. And then on the y-axis, we're going to say cost, which is measured in rands. Let's just say cost rands. Now, remember that this top row is always your independent. So that's this one over here. And then this one over here is your dependent. Okay, now we need to choose a nice scale. So on the x-axis, we only have to go from 1 to 5. So we can do what we did in the previous example. So 1, 2, 3, 4, 5. Okay, you see that fits very nicely. Now we're going to go up to 1,000. So I think if we go up in, let's see here. If we go up in 1, 2, 3, 4, 5, 6, 7, 8. Okay, that wouldn't work nicely. I think, yeah. Let's imagine that they gave us, because we could do like 150, but it's not going to work out so nicely. So let's rather say that there was another 2 blocks. Okay, so excuse me for that, guys. There I went and added on 2 more blocks at the top. So let's just squeeze this in at the bottom. This would just be pairs of shoes. And then we said 1, 2, 3, 4, and 5. Okay, so now what would work nicely now is we could use 100. So 100, 200, 300, 400, 500, 600, 700, 800, 900, and 1,000. Okay, there's a line here. Okay, so now we just go plot everything. So the first one is 1 and 200. So you go 200 and you go 1, and where those 2 lines meet, you put a dot. Okay, so that would be there. And then 2 and 400. So you're going to go across with 400 and up by 2. And where they cross, you put a dot. And then 3 and 600 would be over there. And then 4 and 800 would be over there. And then 5 and 1,000 would be over there. Okay, now you need to decide. Would it make sense to cross these or to put a line in between? It would not, because let's say you chose this point, then that means you're buying 1.5 shoes. Now, 1.5 pairs of shoes. You can't buy 1.5 pairs of shoes. So it only makes sense that we keep it like that with little dots, okay? You don't want to join it. So this is going to be discrete. Okay, and that's everything. We said is it continuous or discrete? It's discrete, and then independent, dependent I showed you, and then we chose a good scale. Here's our next one. So I think you get the idea now. So in this one, a person is saving money. So there's months, 1 month, 2 months, all the way up to 5 months, and then the money saved, they called that S, and it's measured in rands, can be calculated with this formula. So if the months, which is M, is 1, then you plug a 1 over here, then it'll be 800 times by 1 plus 150, and that's going to give 950 rand. So you can just put 950 rand over there, and then you just change the number to a 2, so the next one will be 1,750, and then a 3, you get the idea, hey? What's that, 2550, and then you put a 4. That'll be 3,350. You can just use a calculator just to make sure you don't make any little mistakes. And then with a 5, and that'll be 4,150. Now, our next thing that we need to go do is we need to go plot that over here. Okay, now for months, remember this top row always goes at the bottom down here, so this will be months. And we could say, for example, 1 month, 2 months, 3 months, 4 months, 5 months. Okay, you mustn't do it like this. You mustn't be like 1, 2, 3, 4, 5, because then you're only using this little space. You want to use as much of the grid or the graph as possible. Okay, like that. Now this is quite an interesting one. We got to go up to 4,150, and we've got 1, 2, 3, 4, 5, 6, 7, 8 lines. So this takes a bit of practice. So, I mean, you could practice this. So let's say you chose 500. You'll see that that won't work. So 500, then 1,000, then 1,500, 2,000, 2,500, 3,000, 3,500, and 4,000. You see, it doesn't get to where we want to be. So then you could go a little bit larger. So we tried 500. So maybe now we could try, I don't know, 600 or 550. So 550, then it'll be 1,100. 1,650, that'll be 2,200, 2,750, then it would be 3,300, and then 3,850, and then if you add 550 to that, you end up with 4,400. Okay, so that's pretty good. It captures everything. So that's quite nice. And then, okay, so now we need to go label the axes, or the y-axis. And so this would be money saved. And that would be measured in rands. Okay, now remember that this axis down here is called the independent. You don't have to write the word independent. I'm just writing it there for you so you remember. And then this is the dependent. Okay, so now let's go and let's go plot the points. So at 1 month, it's 950. So 950 would be a little bit under here. So that would be about there. Then 2 is going to 1,750, which would be about here. Okay, it's a little bit in between these two, but not exactly halfway. It's closer to this side, or to this one. Okay, 3 and then 2,550. So 2,550 is closer to this one. So that would be like there, for example. And then this one. And 3,350, which would be quite close to there. And then 4,150 would be probably somewhere in the middle of those two. Okay, so something like that. Now, when you decide whether you can connect the dots, well, there's different ways you could interpret this. Now, think about it. This person's saving money. So we don't know. We don't know if the person is only saving money, like after the month, then they save money, or maybe they're saving a little bit of money as the month carries on. So if they're saving money as the month carries on, then you would be able to connect these dots. Why do I say that? Because even at 1.5 months, which would be somewhere over here, 1.5 months, then they would have maybe like 1,250 Rand. Okay, so then it would be okay to draw a continuous line, because then this would be called continuous data. If they're constantly saving money, like every day, this person is maybe saving a little bit. So they after the first month, they were able to save. Maybe they started at 0, for example. Okay, they started at 0, and then in the first month, every week or every day, they were saving a little bit of money, and so after 1 month, they have 950 Rand. So if you wanted to know how much do they have after half a month, then they would probably have somewhere around 550 Rand. Okay, but so then it would be continuous. But it might also be a kind of question where the person doesn't save money during the month. They only save money when they get paid at the end of the month. Okay, so during the month they don't do any saving, and then at the end of the month when they get paid from their job, then they put savings aside. okay, then you wouldn't connect the dots because there's no saving happening in between. The saving only happens at those places, okay? So it's a bit difficult to know which one to do, but as you practice, you'll get better at knowing what they want from you in the question. So this one could have been continuous, where you put all the lines going through like that, or it could also be, you could also interpret it like this, where you don't put any lines, and then it's called discrete, okay? So all that I want you to know is what is discrete, and that's when it looks like this. Or if you connect the dots, then it's continuous. Okay, I explained independent and dependent. Remember that this top one's also always the independent one, and then the one at the bottom is the dependent. And then we spoke about continuous, discrete, and we also spoke about a good scale. So here's our next question. Now they say that a person is driving a car. Okay, so they're giving us a speed which is measured in kilometers per hour. So that's going to go down here at the bottom, speed. And that's measured in kilometers per hour. And then on the y, we're going to have distance. So let's fill in distance. And that is measured in kilometers. Okay. Now, to fill in the table, you have to use this formula over here. So 60. And then for the first one, the speed is 50. So we're going to say times 50. And that'll give us 3,000. So you're going to put 3,000 over here. And then you're just going to replace this 50 with all of these different numbers, okay, like we've done in the previous examples. So if you multiply it by that, it'll give you 3,600. Okay, and then you can just go and fill in the rest. Okay, and then let's just go fill in the independent. The top one is always the independent, and that's also the one that goes down here, independent. And then the bottom one is the dependent, which is also the one that goes over here. Okay, so we spoke about that. Now we need to speak about a scale. So we're going to go from 50 to 90. Now, what you could do here, because let me show you what wouldn't be that good. Like you could say 10, 20, 30, 40, 50, 60, 70, 80, 90. You see, you're not using all of it. What we could maybe do, if you go in, if you maybe do that, I don't know if we'll have enough space if we do it like this. 40, 50, 60, 70, 80. Yeah, you see that doesn't work. So then what you are allowed to do is we're supposed to start at 0. But if your teacher would have showed you this, and we're going to do this quite a bit in some of the future lessons, if you show like this kind of symbol, okay, then that means we're skipping a whole bunch of numbers, and then you could go straight to 50 over here, and then maybe 60 over there, and then 70, and then 80, and then 90, okay? So you see how we're going 10 each time, 10 apart, 10 and 10. But here we didn't have to put the 10, 20, 30, and 40 because we're showing them this symbol, which means that we're skipping some of them. Okay, that's going to become really important in later lessons. Now, we're probably going to do that again now because have a look here. See, it starts at 3,000. So what wouldn't be that good to do would be to put like 750 here, 1,500. This is wrong what I'm doing now. I'll show you why. 3,000, 3,750, 4,500, 5,250, and 6,000. It does give us all the values, okay? But the problem is that all of these are going to only start up here. So we're only using this part of the graph. We're wasting this bottom part. Because you see, it starts at 3,000. But that's only over here. So that's not the ideal scenario. So what you would do in a situation like this, when all of the values are, that wouldn't be wrong what we just did, but it just wouldn't, it's not ideal because everything would be up here. So what you can rather do is something like this. You can use this funny symbol again. So we can just block, wait, so you just do something like that. And then you could start and you could say something like, 3,000, 3,500, 4,000, 4,500, 5,000, 5,500. Now you'll see that we're going to use most of the graph. Okay, so, because you see how we're going up in 500s, that's meant to say 4,000. Now, we don't need to go put the 2,000 and the 1,000 and all of that down here because we're showing that symbol over there. So the first one is 50 and 3,000. So 50 and 3,000 is there. And then 60 and 3,600 would be over there. It's just a little bit more than that. And then 70 and 4,200, which would be there. And then 80 and 4,800, which would be over there. And then 90 and 5,400, which would be over there. Okay. Now, this is definitely going to be continuous. For example, you can't go from 50 kilometers per hour to 60 kilometers per hour without going through 51, 52, 53, 54. If you're in a car, you can't just push a special button and then all of a sudden you're going 60 and then all of a sudden you're going 70. No, you have to go from 50, 51, 52, 53, 54 up to 60. Okay, so this will definitely be continuous. This one, 100% continuous. All right, and so we can just say continuous. And then we chose a good scale. And that's it. So now we're just going to do 2 more examples and then this lesson will be done. Well done if you've made it this far. Excellent job. So here, this one's a little different. So here they give us a table. So it says complete the table. Now, you got to think, like, how do we complete the table? Well, remember some lessons ago we learnt about what was it? Direct and indirect. And what we found was that with direct, what happened was that whenever you divided these numbers, the answers just stayed the same the whole time. And with indirect, it was whenever we multiplied. Okay, so make sure you've watched that video where we talk about indirect and direct proportion. So if you multiply these 2 numbers, you get 12. Well, let's try dividing first. If you divide 12 by 1, you get 12. 6 divided by 2 is 3. So can you see it's not the same? So it's not going to be a dividing kind of question. But let's try multiply. 1 times 12 is 12. 2 times 6 is 12. So because we're multiplying, it's indirect. So every time you multiply, it must add up to, it must give you 12. So 6 multiplied by 2 gives you 12. 12 multiplied by 1 gives you 12. See that? And now we can just go and plot the values. So this is just x and y. Remember that x is always your independent, or that's the one that's at the top of the table. That's always the one that goes down here. And then your dependent is always the one that goes down here. Let's write it over here. And so now we can just go plot the points. But we first need to choose a nice scale. So on the x values, we're going all the way up to 12. So let's just see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's not bad. We're using up most of it. I don't think we could get any better than that, to be honest. Because if we go in 2, no, if we go 1 there, 2, it will never get to 12. So I think let's settle with that. The idea is you want to use as much of it as possible. Okay, so that's not bad. We're getting all the way up to there. And then here we're going to have 12 as well. But now there's not the same number of blocks over here. So then we can just go in 2s for this one. 2, 4, 6, 8, 10, and 12. So the important thing I want you to realize is that here I'm going up in 1. Here I'm going up in 2s. You are allowed to have it as different things, okay? So that is allowed. Now, the first one is 1, x is 1 and y is 12. So x is 1 and y is 12. That would be over there. Make sure you agree with me on that. Don't just go ahead and unless you fully agree and you understand that. And then the next one is 2 and 6. And then x is 6, y is 2. And then 12 and 1. Oh no, 12 and 1 would be here. Okay. Now, it says here, assume that the data is continuous. So we can connect the dots. Now, when it's indirect, because some of you might want it to go like this. You might want to go, whoops. Okay? But when I showed you this in that lesson where we spoke about direct and indirect. When it's direct, it's a straight line. When it's indirect, it makes a curve. So it's just going to make a curve. Oh, I'm not drawing my curve so nicely. Come on. Like that. Okay? Let's do another one. Last example for this lesson. Okay, that got chopped off a little bit. But this says independent. There we go. Okay, so let's see what we have here. So you see, we don't know what these values are. Now, they haven't, because in the previous examples, I gave you a formula. And that's how you could fill in the table. But now there's no formula. So what we do now is we see, is it direct or is it indirect? So we try to multiply them. That gives you 4. If you multiply those, it gives you 16. Okay, so it's not multiplying. Let's try divide. So 4 divided by 1 is 4. 8 divided by 2, hey, that's also 4. There we go. So what do we have to do? Divide. That means it is direct. Okay, so you need to think about what number must go over here. It will have to be a 12, because 12 divided by 3 is 4. And then what number would have to go over here? It would have to be 24, because 24 divided by 6 is 4. If you struggle with what I just did there, what you could do is you could say this number divided by 3 must give us 4. And then you use mathematics now, like when we used equations to try get this by itself. So we multiply by 3, and what you do to the one side, you do to the other side, so that these 3's cancel. And so you'd end up with A as 12. Okay, that's how I did it. And then I'll do the same for this one. Okay, now X always goes down here at the bottom, and then this one always goes here over there, and then this is always your dependent, and then this is always your independent. Okay, let's see what we have. So we've got the numbers going all the way from 1 to 6. So, okay, so the best would be there, there. You have to keep it at equal spacing, okay? 5 and 6. So that's not bad. We're using up most of the graph. That's okay. And now we need to get 24. So we could go 4, 8, 12, 16, 20, 24. I think we can do better than that. Hold on. 3, 6, 9, 12, 15, 18, 21, 24. Even better. Okay. So the first one is 1 for x and 4 for y. So 1 for x and 4 for y, that would be like there. 2 and 8. So 2 and 8 would be somewhere there. And then 3 and 12. So 3 and 12 would be there. And then 6 and 24. 6 and 24 would be there. Okay, and they said assume the data is continuous. Excellent. So we can go like that. All right, excellent job for making it this far. Thanks for watching. I hope that helped.